Okay, so for this one here, a particle falls freely under gravity from rest at a point P. After it's fallen a second, another particle is projected down from P at a speed of 14.7. And other questions basically, when and where do they collide? And show this on a graph. Okay, so let's have a look here. So I think about it like this: U, V, A, T, S, and we're going to take down as positive. So for the first particle, the U is 0. The V, we don't know. The A is 9.8. The T, we don't know. And the S, we don't know. For the second particle, U, V, A, T, S, I think we said 14.7, didn't we? Yeah, it's projected down at 14.7. The V we don't know. The A is 9.8. Now, here's the thing about the T. If we call the time for the first particle T, so it's using a clock and the clock measures T seconds have passed, well, this guy here, its clock would have to be T minus 1, because when 1 second has passed on this clock, this particle comes into existence and thinks the time is 0. So this minus 1 here is a way to capture the fact that it's on a 1 second delay. The S, whatever it is, has to be the same for both, because we're looking for where they collide. So usually with these questions we avoid looking at the V, and we can get the equation S equals UT, which is 0, and then a half A T squared. And here the S equals UT plus a half A T squared, and they should be equal. So I get UT plus a half A T squared. Oh, silly me. T is T minus 1 plus a half A T squared, T minus 1 squared. Okay, and they should be equal. So you get 4.9 T squared equals 14.7 T minus 14.7, and let's expand this, plus 4.9 T squared minus 9.8 T plus 4.9. So that cancels with that, preventing us from having a quadratic. 14.7 minus 9.8, that's 4.9 T. And then minus 14.7 minus, well, that's, sorry, I've taken care of 14.7 T minus 9.8 T. So minus 14.7 plus 4.9, so that's 9.8, is it? Minus 9.8, take it to the left, becomes plus 9.8. I think T is 2 seconds. Well, there's one way we can check. So the distance traveled by the first particle would be 4.9 times 2 squared. So that would be 19.6 meters. And that should be the exact same distance traveled by the second particle. So S2 equals 14.7 times 2 minus 1, which is 1, plus 4.9. 2 minus 1 squared is still 1. And that's equal to 6, carry the 1, 9, yeah, 19.6 meters. Let's draw this on a graph. Time in seconds, velocity in meters per second. Now I wonder if they're going to be picky and demand that we draw in the V. I guess we better. So for this one here, V would equal U plus AT, 19.8, and we just worked out that this is equal to 2, and this here is equal to 1, and this is equal to 19.6, and this is equal to 19.6. V equals U plus AT, so that's 19.6. V equals U plus AT. So what's that now? 24.6. Yeah, okay. So 19.6 and 24.6. 24.6? Not really to scale. 19.6. 1 second, 2 seconds. So for the first particle, comes into existence when the time is 0, and it reaches 19.6 after the 2 seconds. Then the second particle comes into existence here after 1 second and reaches 24.6 meters per second after a second of its journey has passed. And this area here that's at 19.6 meters area, and then this area here, that's also 19.6 meters area there on the graph. And yeah, I think that takes care of everything they want in that question.